So the first chapter in the book is on functions and models. It is on page 10. And we are only going to do 2 sections from this chapter. So we're going to talk today and probably a little bit about into next week maybe about the 4 ways to represent a function. And then we're going to sort of skip the next 2 sections. And then we're going to talk about section 1.4, how to do some things on graphing calculators. And then, so really this isn't even calculus either. And then chapter 2, when we start talking about limits, because those things get really serious, okay? What's the problem, Jefferson?
You said last year that 2 days. You can teach us calculus in 2 days.
And the rest of the time,
Yeah, you tried.
We should do that.
I did.
You tried.
You already know calculus, so don't, you can just take it now. All right, so here's a little introduction to this chapter. The fundamental objects that we deal with in calculus are functions. This chapter prepares the way for calculus by discussing the basic ideas concerning functions, their graphs, and ways of transforming and combining them. So really, again, we're still just paving the way for calculus. So don't worry about it. We stress that a function can be represented in different ways by an equation, a table, a graph, or in words. And so those are your 4 ways to represent a function right there. Any questions? Okay, here's your homework. One more time. We stress that a function can be represented in different ways by an equation, in a table, by a graph, or in words. We look at the main, what? 10. We look at the main types of functions that occur in calculus and describe the process of using these functions as mathematical models of real-world phenomena. And we also discuss the use of graphing calculators and graphing software. We're not going to use all right, so let's see. Functions arise whenever one quantity depends on another. Consider the following 4 situations. So the first situation is the area of a circle depends on the radius of the circle R. The rule that connects the rule that connects R and A is given by the equation A equals pi r squared. With each positive number R, there is associated one value of A, and we say that A is a function of R. So that would be a way of representing the function using a equation, right? So that's one way that we're going to do it. Here's another example. The human population of the world, P, depends on the time T. The table gives estimates of the world population at any time T. So that's an example of a function using a table, okay? I don't know what just happened. Here's another one. The cost C of mailing a first-class letter depends on the weight W of the letter, although there's no simple formula that connects W and C. The post office has a rule for determining C when W is known. I'm guessing maybe that's in words. That's the best thing. Yeah, they just look at you and go, about 25. And then finally, D, the vertical acceleration A of the ground is measured by a seismograph during an earthquake is a function of the elapsed time T. And so that's a function represented by a graph. So there's some 4 examples of our 4 different dealios, all right? And then in the little box there on page 11, there's a little thing that says the definition of a function, which I am not going to write on the board because you all know it already. A function f is a rule that assigns to each element in x, or each element x in a set B, exactly one element called f of x in a set B. You got that? That's the best definition that they could come up with. So here's how this goes. You've seen this a lot of times before. You have 2 sets, and you have, how did they do it? This is set D, and this is set E. And these are your x's, and these are your f of x's. Okay? And so you've seen this probably before. For this to be a function, nope. If you have some elements in there and some elements in here, then what they're saying is this gets assigned exactly one thing over here. Okay? Now here's the fun part. Remember this? These things can only go to one place here, but you can use these things more than once. Okay? These are your inputs, these are your outputs. You could have the same input give you, two different inputs give you the same output, but you can never have the same output coming from two different inputs. And so that's a little confusing, but for those of you who have my class before, I give you the example of the automobile, okay? So if my input is put it into reverse, my output is the car goes backwards. One input, one output. If my input is I put it into drive, my output is the car goes forwards. My car is functional if every time I put it in reverse, it goes backwards, and every time I put it into drive, it goes forwards, okay? Is there more than one way for me to get my car to go forwards? Yes. Neutral if I want a hill. I'm thinking drive first, second, third, right? Okay? So you can have the same output with different inputs.
Neutral, push it.
What?
Neutral, push it.
Yeah, neutral and push it, yeah, okay. So my point is you can have the same output with different inputs, but every time I put it in drive, the same thing has to happen for it to be functional car, all right? So that's what they're saying with that, all that fancy language. All right, so we usually consider functions for which the set C and E are the set of real numbers. D is the domain, and those are the x's, right? And those are also usually called the independent variables. The range is the outputs, and the dependent variables or the y's. Blah, 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 blah. All right, so let's do this example. So will you go to figure 6 on page 12 and try to answer this on your own. And we came up with this a little bit in our review already, so this should be super simple. So find out what f of 1 and f of 5 are, and also what are the domain and range of that function in figure 6.
Really? It tells you the
Pointing in
answer.
my back.
Right under
Okay, so yes, you could just look up the answer and write that down. But my assumption is that you're going to actually like try and learn.
Well, I mean, like,
Okay, where's
I
figure
went to
6
look
at?
the question, and then I actually looked up the wrong thing.
Okay.
Well, don't make that mistake again.
I got the answer right though.
Okay, good deal.
There's the answer. It's hard.
There's no answer there. We actually had a different one.
I don't see an answer, so I think we should talk about it.
We did this the other day.
Yeah, like I said, we already kind of reviewed this, so this should be easy. So I'm a little nervous that Gabe was just sort of chewing on the pencil and hasn't written anything down yet. I have one. Oh, okay.
I'm gonna go the answers.
Well, maybe I'm wrong.
Okay, maybe you're wrong. We'll find that out in just a second.
Sounds good on the
Yep, that's right. All right, Marcelo, what's f of 1? 3. Okay, go over to 1, we go up to the graph and you get 3. Ashley, what's f of 5? Is that what you went with?
Wait, 75. I didn't.
Negative
Oh, me
0.0.
too.
Okay. All right.
I didn't look at the book. Don't worry. I only looked at
Okay,
the
good. So that's pretty easy. Gabby, what's the domain of that graph? 0 to 7. I can't count. Is that 7?
I can
Okay. And Christian, what's the range? Don't even look. Okay, fine. You got your domain and range mixed up. April, help them out. What's the range? -2 to 4. Yep. Okay. All right. Good. So we're all set on that. Oh, that's fine. Exciting. All right, let's do the next one. So I have graph paper up here if you want to be super fancy, or you can just make a sketch because it does say sketch. Sketch the graph and find the domain and range of each of these two functions. As promised, I told you that we would do this a whole bunch of times, so we get to play again with this fun game. So if f of x equals 2x squared minus 5x plus 1, and of course h can't equal 0 because it's on the bottom there, figure out what f of a plus h minus f of a over h would be. So plug in a plus h for x, and simplify it as much as you can. Plug in a for x. We need to play them together. Okay, let me get you, I'll get you started, okay? So you're going to take a plus h and plug it in there where you see the x's. So I'm going to rewrite this as 2 times a plus h squared, right? Because I'm just putting the a plus h into there, minus 5 times a plus h plus 1, and simplify that out. And then minus, hint, hint, in parentheses, because you're subtracting everything. What do you get when you put a in there first? Right, 2a squared minus 5a plus 1. Okay? So FOIL it, distribute. I just put in a everywhere there was an x. Right? What's that? Yeah, I tried to give you a hint by putting this in parentheses. That negative is going to go through to all those things. So this is going to be a negative 2a squared, a positive 5a, and a minus 1.
I knew the first part.
How did I do this part right here to get to that? I just FOILed it. I did it in my head.
Yeah. Okay. And then you're in the 2 here.
So a squared plus a h plus a h plus h squared, and then these two combine to make 2a.
And then you're
Okay. Okay.
Look at it, I was like,
That cancels with that. Oh, this cancels with that. Okay, so really this is going to be minus 5h minus 2a squared over h, right? So the 1's cancel, negative 5a and the 5a cancel, and then I distributed the 2 through here and rewrote the negative 5h and the negative 2a squared. We okay so far? Okay? And then the negative 2a squared and the 2a squared cancel. And then just like we did the other day, since I have an h in every single term, I can take one of those out. So my final answer is 4a plus 2h minus 5. All right? Okay. And like I said, we're going to play that game a lot, and I'll explain why later, but they're just kind of getting you practicing that a little bit. All right, how about this one? First year algebra problem. So this is the view of a function with words. When you turn on a hot water faucet, the temperature T of the water depends on how long the water has been running. Draw a rough graph of T, the temperature, as a function of the time T that has elapsed since the faucet was turned on.
What graph?
A rough graph? What does it say? A rough graph. That's a rough graph you got there. Yeah, draw a rough graph of T as a function of the time T that has elapsed since the faucet. So it's a direct variation? That's what you would say? What do you mean by that? So here's the temperature and here's the time. So what temperature is the water when you turn it on?
Cold.
Cold. Cold. What happens as you leave the water on? It gets warmer. So we don't really know at what rate. right? That's why it says draw a rough graph of that, because you don't, yeah, I mean, it could go like that, or it could go like that, or it could go like
Well,
that.
eventually,
It doesn't get any hotter.
Eventually, it wouldn't get any hotter. So
Okay, good. That's the
it's
main
now.
point, is that it doesn't really matter what that looks like, but eventually it's going to reach its maximum temperature, and then it's going to level off there, okay? Now we are going to continue to run the water just to annoy our younger siblings. And what happens then?
Like, water
It gets
runs out.
cold, right, because the hot water heater runs out of water, and it might even be... Oh, yeah, you could have a hot water on demand thing with the natural gas, and so it'll just stay like this forever.
Yeah.
Yep.
Yeah.
It'll stay like
I had a
Or
dream about hot water last night. I was in the shower.
dream about hot
Yeah,
water.
and Autumn Cooper was running the sink, and I yelled at her to stop because it was making my shower cold.
That is a strange dream. I don't know what to do with that.
I play soccer.
Okay, I was gonna say, is this just like a random girl that you decided to?
All right, so let's play again.
Yeah, I think I know who she is.
Let's try another one.
Definitely looking at
It says a rectangular storage container with an open top has a volume of 10 meters cubed. The length of its base is twice its width. Now we're having fun, huh? Now you're starting to think. Material for the base costs $10 per square meter. Material for the sides costs $6 per square meter. Express the cost of the materials as a function of the width of the base. What do you think? Not cool?
Oh, that's cool.
How do you want to start?
You know,
How do you want to start? You're all failing right now. How do you want to start?
right.
No.
Highlighting.
Draw a picture, right. We're going to start out by drawing a picture.
No.
Okay? So here is our open-topped container. Okay, so the first thing you're going to do is draw a picture.
Beautiful.
Isn't that pretty? Yeah. You know why I'm a math teacher, not a Yeah. Okay, the length of its base is twice its width. So give me a variable for either the base or the width.
B. No, W.
W. Okay, so this is going to be W, and then it says the length of its base is twice its width. So this is going to be what?
2W.
2W. Okay, does it say anything about the height? No, so unfortunately we have to introduce a new variable in here. Normally we like to just keep it to one variable, but in this case we have no choice.
Figure it out.
Okay, so now that we have a picture, can you answer the problem?
Just figure it out.
Okay, material for the base costs $10 per square meter. What's the area of the base? 2W squared. So 2W squared times n plus, oh, we can figure out the height. You guys are right. Who said we can figure out the height? Because I forgot they gave us the volume, so we don't need to introduce that second variable. So what's the height? Oh, okay, well, let's solve it. So we know that the volume of this is 10, okay? How do you find the volume of this thing?
All of them
Right,
multiply.
all of them multiply together. So h times w times 2w, and that's going to equal 10, okay? So 2w squared h equals 10. So what does h equal?
10, 5 over W squared.
5 over w squared. Yeah, just divide both sides by 2w squared. You don't understand what just happened?
No, nothing. Like, where did we just get 2W?
Um,
way up at the top.
oh, this?
Yeah.
Oh, okay, the area of this rectangle is going to be the base times the width. So w times 2w, and we can laugh at you.
No, I meant that's what I was doing too. I was like,
Oh,
Yeah, I was like,
She's
what?
laughing at
I was like,
she's laughing at herself, okay.
yeah.
All right, so I apologize, we should have done this a while ago. So we're not going to use h for the height, we're going to use 5 over w squared. Okay, so we're back on track now. Everybody know what's going on?
Yeah.
Okay, so the area of the base is W times 2W, which is 2W squared. That costs us $10 per square meter. Material for the sides costs $6 per square meter, so that's going to be a little bit more fun. How do we find the area of the sides? Right, but this side and this side are not the same, right? So I'm going to have to go plus 6 times, what's the area of this face? W times 5 over W squared, which we would like to simplify as
Yeah.
5 over W. Are you okay with that? Because this W will cancel one of those W's down there. Okay, so that's going to be 5 over W. How many faces have that as their area? 2. Take that times 2 plus, what's the area of the side going to be?
10 over W.
Good. 2W times 5 over W squared. So 2 times 5 is 10. This W cancels with one of those down there, so that's going to be 10 over W. And again, there's 2 of those. Yeah. Okay, so express the cost of the materials as a function of the width of the base. Are we done? Heck no. Ah. So we had 2W squared times 10 plus 6 times 5 over W times 2 plus 10 over W times 2. Is that right? Okay. So this obviously simplifies to, obviously, 20W squared. What'd you say, Evan? Okay, so we're going to get rid of the parentheses by distributing 6 times 5 times 2 is 60 over W plus 6 times 10 times 2 is 120 over W. How's that look? Pretty good? Yeah, because they have a common denominator already. Oh, should I add these together? You want to be fancy and make one single fraction?
No.
That girl behind you, whose name I can't remember, Patricia says, no, we're good. You could if you wanted to, and you would get 20W cubed plus 180 over W.
Okay, yeah.
It's a good skill to have. All right? How are we doing?
Good.
Good? No worries? Easiest class you've ever taken? Ooh, that's gross.
Yeah.
What happened here? That's x squared minus x. That's a really heavy exponent for that poor little variable to carry around. Okay. All right. So find the domain of those. Should be a snap.
Can't remember how it works.
Can't divide by 0. Can't have a negative underneath the square root. Oh wait, Kirsten is going or wherever. Where's she still? Augustine. Oh yeah, I don't think she's in this class anymore.
She's too good for us.
That's too easy.
Wait, so what's she counting now? She's accounting.
That'll be good for her.
But she was so good at this.
She's a junior?
Yeah. America's behind. Yeah.
Yeah, those Asians really kick
They're
it.
not even Asian.
Even the
They're
Middle
not
Eastern
Asian.
Asians.
Except for Ari.
Yes, Nate?
Well, like, we're from Russia. Just know that they have class from 8 to 1.
They also start on Saturdays.
Yeah.
That's 6 days a week.
Yeah,
couldn't handle it.
Lana was saying how she has classes 8 to 5. She does have classes.
Screw that, you guys.
And Friday.
Back-to-back World War champs.
Jefferson, you're okay with that?
That's the American spirit.
Back-to-back world champs.
World War champs. So.
Okay, so back to math.
Brute strength.
What's the domain of the square root of x plus 2?
Hey, when it comes to making these big
X can equal -2.
-1.
Oh, you got something against negative 1.5?
Nuh-uh, X can't equal negative 2
Why not?
on the first one.
Yeah, the first one.
Oh, so it can't be negative 0 and 0?
Yeah.
So,
That's all
So
right.
is it the parentheses with the negative?
Yeah, so it can be negative 2. Does it have to be bigger than that or smaller than that? Bigger. So the lowest number it can be is negative 2, and then it can go as big as it wants. Okay. Yeah, you can't take the square root of 0. You can. What does the graph of the square root of x plus 2 look like? Oh, well, gosh, Taylor.
But don't they only take
You
part
know
of
the
it?
square root graph looks like that, right?
Yeah.
The plus 2 is essentially like underneath inside the parentheses, so it's going to move it negative 2 to the
okay.
left, and that's why our domain is from negative 2 to infinity. Great question. All right, and then this is supposed to be 1 over x squared minus x. So we don't have to worry about square roots anymore, but we do have to worry about dividing by 0. So what are the two values that x can't equal? 0 or 1. So if you wanted to write it using interval notation, you would go negative infinity. What's wrong with negative 1?
It can be
Because
one.
it'd be negative 1.
Yeah, this would turn out to be a positive 1 and then a
Plus
negative
1.
minus that. Yeah, so you'd be okay there. So we go negative infinity to 0, and then 0 to 1, and then 1 to... Are those better infinity symbols for you? I went home last night and I practiced.
Yeah.
Well, the top one is a little funny.
This one right here?
Rest yourself.
I did, yeah. But these right here are pretty cool. If I do say so myself. And you know, Mary, from this, the way we got that, the easy way, without just looking at it and thinking about it as you factor it out. Right, so this is 0. Okay. Okay, you're all familiar with the vertical line test, right?
Yeah.
Remember that?
Yeah.
If thing's only a function if there's no vertical line that you can draw. Yeah, the pencil test that goes through 2 points at the same time. Okay, piecewise functions. This seems like we did this already in the
We did
review,
it
but
for...
okay. So if we have f of x is 1 minus f, 1 minus x if x is less than or equal to 1, and x squared if x is greater than 1. What is f of z roll? Say again? 1. I didn't know where that came from. Thought it was game. 1 minus 0, yeah, because 0 is less than 1, so we're in this action right there, so f of 0 is 1. What about f of 1? Are we on the top one or the bottom one? Okay.
So for the top one, we switch the negative sign. We'll just switch the...
No, because that's just saying when you use it. It's not...
Right. So we're not setting this up as an inequality and then solving it for x. We're just saying, we're going back to my little thing I did at the beginning where you have the two things like this. And they're saying, if you are going to plug in a number that's less than or equal to 1, follow this rule. And if you're going to plug in a number that's greater than 1, follow this rule.
So you're just subtracting that value from 1.
Yeah, so if the number that you're plugging in is less than or equal to 1, then just go 1 minus that. Okay? But then magically, for some reason, we decided if it's greater than 1, we're going to square it instead. Okay? And you'll get to do some problems later where there's like 5 different pieces depending on.
Not cool.
So, oh yeah. So what did we decide f of 1 was? So Gabe, let's stick with you. Did you go to the top one or the bottom one?
Bottom.
no, you're doing it.
Gabe.
Oh my god.
Okay, but according to these restrictions, which one does it go into? Is this this situation or this situation? It's the top one, right? Because this says x is when x is less than or equal to 1, use this rule. So 1 minus 1 is 0, okay? And then f of 2, now we're talking about x's that are greater than 1, so we're going to square it and get 4, okay? All right, so if I just make a graph of this real quick, then what does 1 minus x look like?
A line.
A line. Give me more info.
It's going this way and
Okay.
it's up 1.
Okay, y-intercept is 1 and it has a negative slope.
Other way.
Other
Oh yeah, okay. And this is to where x is equal to 1. So right here, it would look like that. Okay. And then x squared, if x is greater than 1. So that's going to look like this, right? What's the value of this function if this was our only function? If x equals 1, what is y equal? 1. So that's going to start in midair here, right? Okay. So I have uber cray. So I have to put an open circle right here, okay? Because this does not allow x to be equal to 1, and then it continues the parabola on like that. Does that open circle make sense? That's sort of like when you're graphing a linear inequality like this, and you would put an open circle there because it can't equal that number. It's the same thing in a two-dimensional graph. Since x can't equal 1 for this function here, that gets an open circle. And sometimes you emphasize this right here. What's that? Oh, okay. I'm sure that it wasn't, but so when we did this problem in the diagnostic test, we didn't have to play this little game because they happened to meet right at that point. But here, since the value of 1 is different than this one, there's that little break in the graph. Okay, so you have to know which place you put the hole into.
so long.
Okay.
Wait, aren't they changing the schedule?
Yes, they're changing the
Mr.
schedule.
Waver complained about
Yeah, Mr. Waver complained about it, so they're
I just have
going
a
to.
serious question.
Okay.
Why would they have the same schedule? Why did they do?
Well, because last year we had 4 flex.
I know, but especially here.
Right.
Why did they not?
I do.
We had conflicts before.
But this like came in the middle. It came like halfway through the
No, it came like
first quarter.
it came after first quarter, I think.
Yeah.
Oh my god.
I love
Oh, yeah.
like semesters.
I know, it's always a good
Hey, I
time.
can do that when it goes like
Yeah.
Okay, awesome.
How many samples are we gonna do?
What time do we get out of here?
that.
There's like
We get out at 30? Awesome. I thought it was 20. Great. You can always tell right here when the show's going to end. So we're page 10 out of 13. So you got 3 more pages to go.
Oh, yes.
Okay, you can do it.
Okay.
All right, find a formula for the function f graph in figure 17 on page 18. So now we're going backwards. I did, yeah. So figure 17 is right there in the middle. Okay, yeah. So that's going to be a little piecewise function. Let me get a little picture of that over here.
It's like a negative
Yeah, it's negative.
No, I think
Yeah.
you
And then it's a line after that.
If we y equals 0.
Okay, so the question is, and I'll change my scale so you guys can see this a little bit better. How many pieces does this function have? 2, 3. I see.
It could be 1 or 2. I mean, 2 or 3.
Oh, so you're trying to make this into like an upside down absolute value one?
Yeah.
Okay, you have fun with that. I'm going to go with Jefferson and go with 3.
I
Nice, easy, linear
But I was
function.
thinking you were leading us into this by asking what
By doing the absolute value. Okay, yeah, I'm totally fine with that. Yeah, you want to figure that out? Go for it. All right, so what is the equation for this piece right here?
Wouldn't it be negative absolute?
Yeah, but it also be shifted
Yeah, so
up
it'd be
and over.
the negative absolute value of x minus 1
Inside the absolute
minus
value.
2 minus 2 inside
Right,
plus 2.
right. So you could do it that way.
Too much work.
Yeah, too much. What's the, this is a little easier, I think, if we say, yes, the equation for this little piece right here is just y equals x. Or you could say what you said, that was good too. And that is when x is what?
Less than 1
And,
equal to.
and,
In between.
right, in between. So we really want to say 0x and 1 like that, okay? Because that little piece only goes in between 0 and 1. All right, what is the equation for this line right here?
Negative x.
It's going to have a
Plus
negative x in it
4.
because it's got a slope of -1, and the y-intercept is 4 if we continued it, so that would be negative x plus 4. And that's for values of x in between what and what? 1 and 2. So I'm going to go 1, and since I already used the equal to there, I'm going to use a less than. I could have made this be the less than and this one be the less than or equal to. It doesn't matter because they meet there, but I can't have them both. Because I need to know if x is 1, do I plug it into this equation or into this one? I can't do both at the same time. Okay? And then what's the equation for this thing right there? 0. Okay, good. And that is if x is what?
Greater than 2.
Greater than 2. And again, I could have said greater than or equal to here and less than here. It's okay, but I can't do both at the same time. All right?
Why is that a weird math?
Why is that a weird math rule? What are you doing? Oh, looking at this. Right. Okay.
It's like less than, because you look at that, and it's like,
When is this page ever going to turn?
Oh, you might as well give this thing
Okay, so this is a little review that we got to that we didn't do before. Okay, even, odd, or neither. Now, hopefully you can look at this and you can make an educated guess right off the bat that this is a odd function because this exponent is odd and so is that one. Here is the math way that you figure it out. If I take and I plug in f of negative x, what is negative x to the 5th power?
Negative.
Negative x to the 5th. And if I plug in negative x for there, then I also get minus x. So since this answer and this answer are exactly the same, but this one is the opposite of that, this is an odd function. Okay? So now let's play the same game with this thing right here, and let's plug in negative x. Now, since I'm raising a negative number to an even power, what is negative x to the 4th? X to the 4th, and then I subtract, and so this gives me the same function that I started with, and that means that this function is an even function. Okay? So if you plug in negative x and you get the same function but opposite, then it's odd. If you plug in negative x and you get the exact same thing, then it's even. Taylor says, what is neither? Well, obviously the last one has to be neither. If I plug in negative x to 2x, 2 times negative x is negative 2x. So this term has changed its sign. But if I plug negative x in there, since I'm going to square it, that's going to stay as negative x squared. So this is neither one. Because one of them switched and the other one didn't. So this is neither. Okay? Okay, and then there's also some symmetries that show up when you graph these, but we'll talk about that at another time. Are you ready?
Page 13.
oh my gosh!
No, let's go back and talk about this more. Okay? Because there's some really fast...
What?
It's your assignment page. Don't get too excited.
Watch, it's gonna add in like empty white pages.
Oh,
Like the
no.
first 30 page day one day. Oh my goodness.
Like 20 of them.
You're not really doing this, are you?
Oh, yeah.
Come on.
Okay, now it's safe to say that you have.
It's first game night though.